Right now, we're going to get started, and we're going to talk about the first of three topics that we need to discuss after lunch today, and that is object references. To give you an idea of what this means, let's look at this inheritance hierarchy, where we have this animal class that is like the parent class here, and then there's a cat and a bird class that inherit from animal, and then this says show cat. That should say circus cat, I think. Let me fix that here. And what I'd like you to do is I would like you to try and code this on BlueJ right now. You don't have to have any methods inside, but just set up the... I have this inheritance hierarchy, and there's animal at the top, and then these two, bird and cat, inherit from animal, and then there's a circus cat that inherits from cat. And so far, let me switch over to BlueJ now. And this is the same exact inheritance hierarchy shown on BlueJ. You can see I've got the animal class at the top. These two inherit from animal. This one is circus cat inherits from cat. And then there's a tester class that has the test code in it. So we would say that these white arrows here represent ISA relationships. We would say a bird is an animal, a cat is an animal, a circus cat is a cat. And in here, these dotted lines represent has a relationship. It represents containment. We can see that the tester has these different animals inside of it. So let's look at this code for a second. And you can see here inside my main method, I've created an animal, a cat, and a circus cat. And the new wrinkle that I want to throw into this little party here is, can we ever mix these? So let me put together some potential convoluted ways of pointing to these animals. Now, so far, I have used the term variable to describe A, C, and CC. Starting today, they're still variables. Starting today, I'm going to use another term which is synonymous with that. I'm going to call them pointers. I'm going to say that A points to an animal object, C points to a cat, and CC points to a circus cat object. That's terminology I'm going to use going forward, and you'll see why I'm going to prefer that terminology to just using the term variable. I want you to discuss with your partner. Now, I'm going to comment this out initially because I don't want the compiler to give away the answers. But I want you to think about now, do you think this would work? Like if I go A equals new cat, would that, number one, would it compile? If it compiles, why would we ever want to do something like that? Let's look at another one. Let's look at, I'm going to add one more here. I'm going to say bird B equals new bird, right? And we know that's going to work also, right? Now, these I've commented out, so we won't know if they work or not just yet. But do you think this would work? Like if I go B equals new cat, would that work? And what about this one? How about CC equals new animal? Or maybe CC equals new cat. Maybe that could work. Or perhaps A equals new bird. Or maybe we could really live on the wild side and say A equals new circus cat. And what I'd like you to do is get together with your partner for a few minutes and discuss with them which ones of these do you think will compile, which ones do you think won't compile, which ones kind of intuitively make sense and which ones don't make sense. Please get together now and go through that brief exercise. If you're struggling with this and you're not really sure where to even get started, let me give you a few hints. You see this A pointer I have, right? You can see that it's been declared to point to animals. So the question is, the thing on the right-hand side of the assignment statement, is it an animal? That's the question. Is it an animal? And if it is, then I think we're okay. If it's not an animal, then we're not okay. Now let's look over here. This thing B, it points to birds. Is that a bird on the other side of that assignment statement? I'm not sure. Now this thing here, CC, this points to circus cats. Is there a circus cat on the other side here? Go through that same questioning for all of these. Try to figure out which ones will compile and which ones will not compile. So I think you'll agree with me it's confusing, right? It's not so clear what's happening. And I'm going to show you a surefire way of making sense of this that will make it much easier when you get to the AP exam and you're not sure which of these work and which one of them don't. The secret is to draw a Venn diagram. Let me show you what a Venn diagram looks like for these relationships. So we're going to go back to our picture over here. Now, this is not a Venn diagram. This is an inheritance diagram. I'm going to transform this inheritance diagram into a Venn diagram, and then it looks like this. I think you'll agree with me that the yellow part here, which is the animal, encompasses everything. Bird and cats are types of animals, and then the circus cat is a type of cat. So this inheritance hierarchy is equivalent to this Venn diagram. Do we all agree with that? And now the rule for pointers is extremely simple once you have the Venn diagram like this. If I have an animal pointer, like let's say I have a pointer that's in this yellow range here, it can point to animals and everything that's inside of animal. So for example, if I have an animal pointer called A here, it can not only point to the yellow region, but it can also point to this beige region, the green region, and the blue region. Because this pointer encompasses this entire area here. Likewise, if I have a green pointer in the cat region, like cat C equals something, what things can it point to? Cats and circus cats. You can see that all circus cats are cats. See that? Last question. If I have a pointer that points to circus cats, what things in this inheritance hierarchy can it point to? Only circus cats. You see that, right? So that's the general idea here. So looking at this Venn diagram, let's go back to our picture here and have a same discussion again about which ones of these will compile and which ones will not compile. So I'm going to go down the list here. Ms. Omkumar, how do you feel about this one? A equals new cat. Yes or no? Yes. Yes. So we'll try it. You can see that this compiles just fine. We'll talk in a minute about why we would ever want to do this, and there's some really good reasons to do it. Now let's try this one. Ms. Malhotra, how do you feel about this one? That will not compile. You can see it's no good. So I'm going to have to comment that out in order to keep going here. Now let's look at this one. And let's see here. Ms. Caitlin, how do you feel about this? It will not compile. You can see here, going back to our picture, you can see that pointers in this beige region cannot point to objects in this green or blue region here, so that will not compile. So I'm going to have to comment that puppy out also. And now let's look at this one. And Mr. Borden, how do you feel about that? It's confusing, isn't it? Will not compile. That's correct. You see that, right? What if it was the other way around, sir? What if I had a cat pointer here and a circus cat here? Then that would be okay. See that, right? But this is not okay. So we need to get rid of that. And how about this one here? Mr. Menez, how do you feel about this one? That works. See, this is an animal pointer, and this is an animal. Yes, it's a bird, but it's also an animal. So you can see that that one compiles just fine. And lastly, how about this one? We skipped an inheritance level here altogether. What do you think about that, Mr. Sneed? That one's okay also. You can see that one's okay too. So I think you have a pretty good idea now of what works and what doesn't work. I'd like to go back to this example right here and talk a little bit about why we might want to do that. Let's look at this diagram right here. In our little example, we have two classes that inherit from animal. I want you to imagine now, instead of having just two, we have like a dozen different classes that all inherit from animal. These like bird, dog, reptile, fish, whatever. A lot of times what happens in the code, you have a pointer, and you don't know what animal you have on the other side. Well, how can that be? Well, imagine for a second that you had a menu, and you told the user to select one item from the menu that would create a new animal. But you don't know ahead of time what they're going to pick. So maybe if they pick a choice A, you create a bird. Maybe if they pick choice B, you create a reptile. Choice C, maybe you create something else, right? fish maybe. So a lot of times you create objects, you don't know what type they are, so you need something more generic to be able to point to it regardless of what it is, as long as it's in your inheritance hierarchy. So this pointer is only restricted to pointing to animals. It can point to any kind of animal. It can point to a generic animal. It can also point to objects that are derived from animal class, like this cat. So that's really valuable to use.